Hello, my name is Ben McDonald, and today I'm going to be walking you through an Arkouda Lightning tutorial, we're calling it, where what Arkouda is a NumPy-like Python package for interactive supercomputing at scale. And so essentially, if you're working with NumPy, you're limited to the memory and the resources you have accessible to you on your laptop, but Arkouda has a client-server model where you're able to run your Python client that's running your Arkouda client from your laptop, something like a Jupyter notebook like I'm showing here, and then connect to an Arkouda server that's running on your supercomputer, which I will also be showing here as well. And so what we're going to be doing here today is working through this Parquet taxi cab data, which is a public data set available at the New York City government website, where you can see information on taxi cab rides in New York City. And then, yeah, so this is a real world workflow, a real data set. So let's get started. And so what I'm doing here is I've launched an Arkouda server on eight nodes of a supercomputer. And this supercomputer, each node has 48 cores with 192 gigabytes of memory per node. And it also has an Aries network. So that's the machine we're running on. I've started the server on that machine. I have tunneled into that machine from this terminal. And then in this terminal, I've started my Jupyter Notebook server on my laptop locally. And so let's get started. So the first thing we're going to want to do is import our Arkouda package and then connect to our Arkouda server, which is located on the supercomputer. And then here I've just got some other imports for packages we'll use throughout this demo. And so the first thing we have to do here is read in our Parquet taxi cab data, which I have stored on the supercomputer. And so if we'll read that in, we see that takes about 1.3 seconds. And that's about 342 gigabytes that we've read in there in 1.3 seconds. Very compressed data, so I won't spend too much time harping on that read time, but yeah, a lot of compression going on there. But in memory, it expands to 342 gigabytes, which of course you couldn't use on your laptop in NumPy. So just showing off how we are using this backend server with 342 gigabytes in memory there. And so now visualizing this data, what we see is a bunch of information about taxi rides, where we have something like, like their pickup time and their drop-off time. And then we can also see things like number of passengers in the ride, the trip distance, and the fare amount, and that kind of thing. So kind of just all the information you could hope to have on some taxi cab rides. You've got it with this New York City data. And so from there, if we just do some quick description of that data with Arkouda, what we see here is our average fare from all these rides is $18. Our minimum ride is, the minimum fare was negative $500, and I don't have a clue what that means in reality. And our maximum fare was about $4,000. So hope that guy got his money worth. And I'm realizing I have neglected to mention what we are reading in here is all of the taxi cab data on New York City from 2020 to 2024 as of this month of August. So yeah, so now we've got our kind of descriptive statistics. And so all of that was calculated on the server side. We didn't have to pull any memory down to the client. All the data is stored on the server. The client remains kind of ignorant to the amount of memory that is being used here. And so the next thing that I'm going to show here is a histogram with Arkouda, leveraging matplotlib. And so when you do something like a histogram in Arkouda, what you see on this graph is essentially like you calculate the number of bins and then the number of values that is going to go in each bin. And so what that means is you don't actually have to have all of the data on the client side to calculate it. You just kind of need that small subset of the data. And that's why we're able to pull that down to the client side and work with matplotlib. And so what you'll see here is a pretty normally distributed data set based off of the fare amount here, with a couple of extremely expensive rides thrown in there, where yeah, I see we have a single 4,000 and one around 3,500. And so now this next part is calling a group by in Arkouda. And group by is really Arkouda's kind of like bread and butter. It's what our users are most happy with about Arkouda. And what a group by is it's essentially a sort of data using multiple keys. And so that way you can now think of this. So in this case, we've group byed our data set from the pickup location and the drop-off location. And what that means now is you can think of this group by object as kind of you now have this separate index where you can use these two keys to index into that data. So every ride that started from this pickup location and every ride that ended at a drop-off location, those are now considered a single unit. So you can make some interesting claims about the data. And so what we'll see here is we had 36 gigabytes of data in this row, and we sorted that in about 0.7 seconds. So just another reason why the Arkouda server is great in this case. We have like a huge amount of data. We're sorting it very fast. So that's what Arkouda is meant for. And so due to time constraint, I won't go over too much detail what we're doing here, but we're just doing some statistics, calculating the mean and the standard deviation of this before broadcasting it back out to our Arkouda server. So we can now have that in our data set. And so you'll see kind of like this mean and the standard deviation calculation were both pretty quick, a 1 second, well within the human thought loop. So you can keep working as a data scientist, regardless of how much data you're working with. And so now visualizing this data one more time before kind of wrapping it all up here, what we see here is essentially the same data set we saw originally, except we now have this fair mean and the fair standard deviation associated with each row. And that is coming from this broadcast command, which took our group byte object, everywhere that had the same pickup location and the same drop-off location, and appended this average fare, or like appended their mean fare onto each one of those fares that had that matches that pickup location and drop-off location. And so let's just take a look at this one, for example. So here we have the average fare for this one was $10, about 9.99, and this guy paid almost exactly that. Here we see, let's see if there's one a little more interesting. Okay, here's one. This guy paid about $10 for his ride and paid $20, so he paid about twice as much as he should have, and he still left an over 20% tip, so a generous guy. And now lastly, just kind of plotting that histogram again one more time over the fair z-score here, the standard deviation of these values. We see a pretty standard, normally distributed graph, just like we were seeing before, where most rides are falling on the more expensive side rather than the less expensive side, with the expensive rides getting much more expensive than the cheap rides are cheap. And so now that we've gone through all that, we can kind of tie it together here with the real takeaway here. Which was my goal in looking at this data set, to find the worst ride in all of New York City over the last 4 years. And so what we see here is somebody who had a fair z-score of 23. And what we'll see is that they paid a total of $423 for this ride, whereas the average fare was about $750. So this person paid about 60 times the average fare. He could have, most people, 60 rides are typically what goes for this. Yeah, so that is the Arkouda demo. Thank you for coming. Yeah.